So yesterday we were discussing this question, right? And we tried to find the positive and the negative value of areas, and then we found the net distance traveled. We also found the net displacement, right? How do you find the displacement? You subtract from the positive the negative area, right? This was a positive area, this was a negative area, this is what we did. Remember? Yes or no?
Yes.
So I think the answer for the first part was 550 meters. For the second part it came out to be 1550 meters or 1050, something like that. 1050? Yes. Because this was the distance, so we had to add the area of this and this, isn't it? 1500? 155, that's what I was asking, okay. So it is 1550, okay? And then acceleration, I think it was negative 4 meter per second square, yes? And this was something where we stopped actually. Name a time when the velocity is increasing but the speed is increasing. So yes, so I think I named this O, this has A, this has B, this has C, this has D, and this has E, right?
Yes.
Now, what is the answer for the D part? See, you need to understand. Velocity is increasing. From negative 40 to 0, velocity is increasing, isn't it? Less, see, understand, very important. How do you understand is velocity increasing or decreasing? If from less positive to more positive, it's increasing. If from more negative to less negative, it's also increasing. So yes, it is increasing from D to E, correct? At the same time, it is also increasing from O to A, clear? But the other part is speed is decreasing. What is speed? It is the magnitude, isn't it? So here the magnitude is 0, here the magnitude is 60. So the speed is increasing in O to A. But here from D to E, from negative 40 to 0, what we have seen that magnitude here was 40, which was already high, and here the magnitude is 0, so the magnitude is reducing. That means it is slowing down. Therefore we can say D to E. I think we did this, right?
Yes.
Now what about this? Name a time when the velocity is decreasing but the object is getting faster. So the speed is increasing.
C to D.
Yes?
C to D.
C to D. Anyone else? See, there are two possibilities where the velocity is decreasing. First, B to C. Is it decreasing? Yes. From C to D it is also decreasing. Why? From less negative to more negative. It is decreasing. Or increasing in the opposite direction. Is that clear? But he is saying body is getting faster. From B to C the magnitude is reducing, so it is slowing down. But from C to D the magnitude is increasing, therefore it is getting faster. So yes, it is true that it is from C to. So are disposition time graphs and velocity time graphs clear to you guys?
Yes.
Yes or no?
Yes.
Okay. Now we have the last type of graph, and that is what? The acceleration versus time graph. Okay. Now understand, acceleration time graph can be plotted if you already have velocity time graph. Okay. And very important thing. From acceleration time graph, if you take the slope, you will get jerk. If you remember, I told you last time. If acceleration is changing, then what will you get? You will get jerk. That will not be asked from you. But what you will be asked is, from the acceleration time graph, calculate the velocity. Fine? So how do you calculate the velocity from acceleration time graph? There are two methods of calculating velocity. First, from the slope of position time graph. Or, very important, from the area of acceleration time graph. Is that clear? So if you take the area of acceleration time graph, the area will always give you what? velocity. Is that clear? You have to remember this. Area under the graph will give you velocity. Clear? So see, there is an acceleration time graph. What is the acceleration from 0 to 2 seconds? Yes, it is 2 meter per second square, isn't it?
Yes.
Then from 2 to 4 the acceleration is 0, and then from 4 to 5 the acceleration is negative, isn't it? Now tell me, if the acceleration is constant, can I say the velocity is increasing? Can I say the body is speeding up? Yes?
Yes.
Why? Because acceleration is constant. What is acceleration? It is the change in velocity. And acceleration is positive as well. So it means velocity must be increasing. Is that clear? What is the acceleration from 2 to 4? 0. So when the acceleration is 0, what does it mean? Two possibilities. Either the body is at rest or the velocity is constant. Is that clear? Is it clear? What about this? Yes. Acceleration is what? Negative. Negative acceleration means retardation. Is that fine? So that means the velocity is decreasing. Clear? Clear? But at a constant rate. Now see, we have to plot graphs. The question is, plot a graph in which you have zero acceleration. Acceleration has to be zero. So first of all, let us plot the acceleration time graph. Acceleration versus time graph. When the acceleration is zero, the graph will be something like this. See, the graph will be something like this. Zero acceleration, isn't it? But when the acceleration is zero, what will velocity?
Zero.
When acceleration is zero, there is no acceleration. What will be velocity?
Zero. Constant.
Or constant. So can I say velocity time graph will be constant? Yes? We can also say this. No problem in this. Velocity time graph can also be this. Velocity is zero. Acceleration also zero. Is that fine? It is possible. Because there is no change here as well. Fine? And then if you see one more thing, very important thing. If this is the case, that velocity is constant, how do you get velocity from position time graph? Yesterday we did it. How do you get velocity from position time graph? From the slope, isn't it? From the slope of position time graph, we get what? Velocity, isn't it? Now tell me, what is the velocity? Is it constant? Yes? So does that mean the slope of position time graph will also be constant?
Yes.
When the slope will be constant, how will the graph look like? Straight line, isn't it? Because a straight line has, yes, this is the position time graph. The position time graph will be a straight line. The reason is the slope of this graph is straight, is constant. So when the slope is constant, it means velocity is constant. Therefore, this graph. And when the velocity is constant, acceleration will be zero. Is that clear? Just one information was conveyed, zero acceleration. And from this we can plot three different graphs. At the same time, very important thing, I told you when acceleration is zero, there are two possibilities, isn't it? One, the body must have constant velocity or zero velocity, isn't it? When the velocity is constant, position time graph will be like this. Because there is velocity, the body is in motion, so body is moving, distance is changing, isn't it? But if velocity is zero, then can you tell me how will the xt graph look like? Exactly, the distance will be constant. Is that clear? When you see, what is the slope of position time graph? Velocity. But what is the slope of this graph? Is it zero? Yes? It doesn't have any slope. When there is no slope, velocity is zero. Velocity is zero, acceleration is also zero.
So there's no graph of the acceleration?
For this? No, the same graph.
No, for acceleration time graph.
No, that is a different thing. No, this is different. Don't go there. This is one portion. So if he says A body has zero acceleration. See, you know this graph. But from this graph, we have plotted four other graphs. Just by understanding the definition, the slope, the area of the graphs. Is that clear? Now someone is telling me a body has constant acceleration. A body has what? Constant
Acceleration.
When the acceleration will be constant, how will the acceleration time graph be? Yes? Won't it be like this? Yes? Now there is acceleration. So there is acceleration. When there is acceleration, tell me what is happening to velocity. Is it changing or no? It will change, isn't it?
Yes.
But how? How is it changing? The acceleration is constant. That means the slope of velocity time graph will be constant, isn't it? So therefore, by default, your graph has to be what? A straight line, isn't it? Is that clear? So the velocity time graph will be like this. Why? Reason? Reason is what? Acceleration is constant. So acceleration is obtained from the slope of velocity time graph. Because acceleration is constant, therefore the slope also should be constant. So in this graph, slope is constant. Is that clear? But now this is velocity time graph, and you are seeing that with time, velocity is changing, isn't it? Isn't it? So is it increasing or decreasing?
Increasing.
Yes? Increasing, isn't it? How do you get velocity from position time graph? How do you get velocity from position time graph? From the slope again, isn't it? From the slope of position time graph, you get velocity. But is the velocity same throughout? No, it is changing. When the velocity is changing, that means the slope of position time graph will also change, isn't it? When the slope of position time graph will change, will the graph be straight line? No, it's not. Therefore, something like this. Why something like this? Why not something like this? Because here it is decreasing. How big, but our velocity is continuously increasing, isn't it? Because velocity is increasing, therefore only this is possible. This is not possible. Is that clear? That is the reason. You need to understand what is happening. Clear? This is it. Now you have a question. Classify the velocity at each point of the position versus time graph and sketch the graphs for the velocity and acceleration. Okay, this is a position time graph. We have to plot, from this we have to plot its velocity time graph. From this we also have to plot its acceleration time graph. Is that fine? That will be the last assignment from this unit. Okay? So, look at the graphs and tell me. What about the first one? First one. Yes. Tell me, what is happening in the first part? Position time graph. Distance is increasing. Is the slope constant? When the slope is constant, what do you mean? Velocity is constant. When velocity is constant, is there any acceleration? Very good. So, see the first step. First is constant positive velocity and zero acceleration. Is that clear?
Yes.
Is that clear? What about second, Hiba? See what is happening in the second part, yes? Here the slope is a little more, isn't it? As see, here it was less steep, but in the second portion it is like this, is it? So, in the second portion, the slope is again constant. That means velocity is constant. When the velocity is constant, what will be its acceleration? Again zero, isn't it? Very good. Noora, what about the third one? Yes? What is constant? Just look at it, don't guess. In the third part, what is constant? Yes, Tagri? In the third part. Exactly. Because see, this is position time graph. What is the slope? Zero. When the slope is zero, velocity is zero. When velocity is zero, what is acceleration? Yes?
No.
0, yes. So see, this is the third part. 0 velocity, 0 acceleration. Clear? Yes, you? What about the fourth part? Here. What do you see? Is the velocity changing? See how you read the graph.
Yes.
Is the velocity changing from 4 to in the region 4? What is the slope initially, more or less? And then
Yes.
is the velocity decreasing?
Yes.
When the velocity is decreasing, what does that mean?
Negative.
Negative acceleration, khalas. Oh, what is the difficulty? So let's go. See, in the fourth part, here it is. Decreasing positive velocity, isn't it? Why decreasing? You need to understand. Because initially the slope was very steep, but as you go up, it's getting less steep, isn't it? So slope is decreasing, it means velocity is decreasing, but it is still positive, isn't it?
Yes.
Therefore, it has retardation, negative acceleration. Is that clear? What about point 5? Yes? What about point 5?
Decreasing.
Okay, what about 5? What is happening at
This
5?
one is this.
No, it is a little.
Decreasing.
Yeah. See, at 5, we are having a negative slope. Negative slope itself means negative velocity. But that negative slope, very important thing is, see, here the negative slope is something like this, isn't it?
Yes.
But if you take the point here, then it is more steep, isn't it? So it was less negative here, but here it is more negative. So what is happening? From less negative to more negative, it is? So therefore, we have an increasing negative velocity, because from negative 2 to negative 4 it is increasing in negative. Is that clear? Is that clear?
Yes.
Okay, and therefore, but because the slope is negative, the acceleration will also be negative. Is that clear?
Yes.
Is that fine? Okay. And the last. See, for the sixth point, it is a straight line, isn't it? For the sixth point, yeah. For the sixth point, what do you see?
Constant.
This is a straight line. So it means velocity at every point is same, but is it positive or negative? Very good. What about the acceleration then? 0. Why? Because the velocity is constant. See, what does that mean? For the sixth portion, the velocity, because the slope at every point is same, okay, so we can say if it is negative here, negative 2 here, here as well it is negative 2, here as well it is negative 2. So there is no change in velocity. When the velocity is not changing, acceleration will be what? 0. Why is there acceleration negative in the fifth part? Yes? Because see what is happening. In the fifth part, in the fifth portion rather, it is less negative, it is more negative. So velocity is changing. Is that fine? And getting more negative. Therefore retardation is negative acceleration. Is that clear? Okay, so this is the last case as well. Clear? Understood everything? Now from this graph, at your positions, I want you to plot velocity time graph. Velocity time graph for the 5 portions. First, second, third, fourth, fifth, and then sixth. Plot velocity time graph on a single graph for all the 5 or 6 parts. Try to plot it. What is the velocity in first part? Constant. What is the velocity in second part? What is the velocity in third part? 0. What is the velocity in fourth part? Decreasing but positive. What is the velocity in fifth part? Increasing but negative.
Is it the same thing?
No. Here it is positive. Here it is negative.
Not about the same as the position time graph, the answers.
Yeah. You have to plot the velocity time graph now.
So the same thing.
Yeah, no, the graph will not be same. You have to plot, see, what is this? This is increasing. But if you have to plot the corresponding velocity, it will be 0. What is the velocity here? Again 0. So it will be again like
I'm
this.
talking about this, like if it's a velocity time graph, the same answers.
Answers are same. From this, the answers of this will be plotted there. Understood? So this is the information. From this you have to plot, like it is simple, like we did it here, see. See what we did here. We had one information, right? From this we plotted other things. Same thing you have to do in the right. Yes, this is the graph. The one who will do it first will get a reward. Plot the velocity time graph and then plot the acceleration time graph. The velocity time graph and the acceleration time graph. In the first portion, velocity is positive, right? In the second portion, it's again positive, right? What is the slope say? Well, the slope is going, so one is more, one is less. Three is the straight. No. Leave it. Now go for the fourth one. No. Is this your time? No. 0, 1, 2. It's again 1. It's not strange. 2 to 3 is 0. Then 3 to 4. 3 to 4, what is happening? It is decreasing. You should start from high, right? Okay. Then decreasing. Because at the top, push point, it will be 0. Top. But from 4 to 5. No. In the fifth part, fifth part is negative. And in the sixth part, plot it. Now, you know this plot acceleration, right? This, yeah, you can do that. But the second will be there because it is more slow, isn't it? So instead of it will up, a little up. In the third it is 0, isn't it? In the fourth it is 0. Khalifa, yeah? Khalifa, did you? Where were you yesterday? You were in charge? Does he charge less? And I also want to put you at this. How come? Constants, but the constants are not same. One is this, one is this. Where were you yesterday? I know you were. You don't give the girl. How will it be? Okay, we know that. how did these two change? Which the slope? Where is the slope? One is like the first is this, second is this. Yeah. Please show me. What is where? Oh, you. Yeah, that's good. There is no slope. This is what? It's not increasing, it's decreasing. Or below increasing. Oh my God. He has plotted my heart rate.
Because it's decreasing.
Haldi Kharab. Oh. Zero. Last portion zero. 6, 0. Velocity is constant.
What is
Velocity constant, please. Is it acceleration or what? Oh, velocity is negative. Fine. Yeah.
what is for?
What is?
Goes down.
You can take help from this. Yes. Yeah. Oh no. This is again wrong. Still wrong. Wallahi. गलत हो गया वो? What do you call wrong in Arabic? That's what I said.
No, it has to be down.
But this now no reward. But this portion is but where is the part? You have plotted. Hey, hello, see. Where is that? Show me. You plotted it right. Yeah.
I don't understand 4 and 5. Anything else I understand.
4 and 5 you don't understand?
No, I don't know how to put it into velocity time.
But whatever we wrote here, first of all, you understood.
Yeah. Just
Yeah.
to convert.
Tagreed, no? Still no? Same? What did you say? Yeah, you are. Where is your point? The fourth point. Decreasing positive. Yes. Yes.
Zero.
Third one, zero. Fourth.
Zero acceleration. Negative acceleration. Negative acceleration.
Yeah, exactly. Good. How? What do you do? You have. No, this is one. And then 4 and 5. You give up, you go on. Last 1 week has been the same. Agreed, no? For the acceleration. 0, 0, 0. There is only one acceleration, right? That is negative. 4 and 5 negative acceleration class. 1 and 2, 3 also 3. Okay, let's come back. You? Sure? Oh, wrong. See, khalas.
There's something like this. Because from 0 to negative.
But it is positive decreasing.
That's my question. I don't understand.
Okay, now see, please come here. If I was asked to plot a graph, which is now, see, this is the original graph, right? Let me first of all clear this. Because I want to make you understand how will the velocity time graph be. See, if I plot the velocity time graph on the same thing with the help of red ink, then from 0 to 1, what is the velocity? Is it constant? Isn't it? And it is positive. So it means if it was velocity time graph, then for example, the velocity was something like this, constant. For the second portion, this, it is also constant, but the slope is more. So that means, is that clear? No problem. In the third portion, there is no slope, so velocity is 0. Khalas. Is that clear? In the fourth part, you need to understand the velocity in fourth part is positive at every point, but it is decreasing. It is decreasing. Is that clear? So when it is positive and decreasing, and at the topmost point, can you tell me what is the slope? 0. Isn't it? So that means if the slope here is 0, velocity at the top is 0. So that means you have to show something like this. 0. Is that fine? And then for this portion, up to, for example, this point, the velocity is what? Negative, but increasing. Negative because it will be below, and increasing. Increasing means, is that clear? And for this portion, the slope is constant, velocity is constant, but is it positive or negative? Negative, khalas. Now what is the difference? Understood? Anyone, any doubt? See the graph. Here the velocity is this, second portion it will be somewhere here because the slope is different, it is incorrect here. Third portion it is 0, fourth and fifth it is decreasing, and then it's constant. That's it, khalas. Is that clear?
Yes.
Can you tell me what will be its acceleration? How will its acceleration be now? What is the acceleration in one? What is the acceleration in second? What is the acceleration in third? So acceleration is 0. Up to this point, isn't it? From this point to this point, what is the acceleration? And positive or negative? Negative. Why? Because velocity is decreasing, isn't it? That's it, khalas. And here again it is 0. So acceleration is much easier. Only negative here. Everything 0. 0. Isn't it? Mr. Moyed is drawing something like this. How come? Is it clear? Do you have any doubt? If you have, please let me know. This is one of the most informative questions that you will get. Because everything is asked and everything, see, from a single graph you are plotting everything and you are also understanding what is happening. That is why I told you in the beginning, whenever you do kinematics, graphs are very important. If you can distinguish, if you can understand the language of the graphs, it will be very easy. But if you cannot, then the equations don't help. Is that fine? That is it. Last question for the day, much easier, and I would like you to, for God's sake, solve this question. Do it here. The graph on the bottom shows the velocity of the alpha graph. Okay. Now the question is the velocity time graph. See, please see, velocity versus time graph. Okay. This is the origin, 0. So the question is, when is the alpaca at rest? When is the alpaca at rest? Exactly when the velocity is? When body will be at rest only when the velocity is? When is the velocity 0? Yes? Isn't it? So it is at rest at time t equal to 5 seconds. Is that clear? It is clear? Is it clear? Okay. What is the acceleration of the alpaca at 4 seconds? Acceleration at 4 seconds. Yes. Is it positive or negative? Very good. Why? Because at 4 seconds he is on this path. So let me name them O, A, B, and then I can say this is C, and then let this be D. Okay? So when he is asking about 4 seconds, so alpaca is here, isn't it? The question is, what is his acceleration? Which graph is this? Velocity time graph. How do you get acceleration? Slope. So try to calculate the slope of BC. And how do you calculate the slope? You know that? Perpendicular upon base, isn't it? So let this angle be theta, make this as a triangle. Is that fine? So the tangent of this theta will be equal to perpendicular. What is the perpendicular? 0 to 20 upon base. Base is how much? 3 to 5. It is? So the answer is 10 is the slope. But what is the acceleration?
Negative.
Exactly, negative. Very good. Negative 10. Because it is decreasing. Is that clear?
Yes.
Now the question is, where does the llama have no acceleration? Where does it have no acceleration?
A to B.
Exactly, A to B, because the slope is 0. Good. Okay, now the last part. If he continues his negative acceleration for t more than 3 seconds, okay, when would he return to its starting push? So the question is, see what is happening. Do you see that when he is at 3, he has started to retard? Yes? The question is, after how much time? If he continues like this, after how much time will he return to its original position? When someone returns to his original position, what is the displacement? Very good. So do you see up till 0.5, up till this point, we have positive displacement? Yes? But after 5, from this point, he has negative displacement, isn't it? So he says when he continues like this, somewhere we will have a point, somewhere we will have some value of time, let that be for example t, when the area of this portion, which is the negative, will equal to the positive. When the positive and negative will be equal, net will be his displacement is 0. When the displacement is 0, we understand that the alpaca will be back to its original position, isn't it? Because this is a velocity time graph, and from the area of velocity time graph you get displacement, isn't it? So the question is, when will he return to his original starting position? So when he returns, we have to say displacement should be what? 0. That means the area should be what? 0, isn't it? And how will the area be 0? Yes, when the area of the positive half equals the area of the negative half. Is that clear? Is that clear?
Yes.
So that is what we have to do. Khalas. We have to find the area of this and then equate it to the area of this. Is that fine? Try to do it and give me the value of t.
You forgot to answer the questions.
Yes, sorry.
We want to see the graph.
You want to see the graph?
Yes.
Okay, look at the graph.
We need to find the area like that.
You need to find the area.
So,
For this, how do you find the area? This is the area, right?
yes.
Isn't it? How do you find it? Yes?
Depends on the shape.
Mm-hmm.
It'd be a
No, it's not rhombus. How do you find the area of the positive part? Yeah, we'll section it. Simple. Break it into simpler segments. You can segment it like this, for example. Now it is a trapezium. This is also a trapezium. You can find the area. Or you can break it into triangles. Whatever you like.
When you put the formula for the
What is the area of a trapezium? Yes, half of sum of parallel sides multiplied by the corresponding height. This is the area. So try to find the area of the two trapeziums, that will be the area.
area equals
Can you go back to the graph?
Back to the graph.
Thank you.
We can do it here only if I'll erase everything if you copied this. Have you copied everything? Yes?
yes.
So should I erase it? See, if you have to find the area of 0A, B and C, okay, so what I will do is I'll try to break it into two trapeziums. Is that fine? So what about the area of this portion? Yes, half of the parallel sides multiplied by the height. So that would be, I'll write area of positive portion. That would be equal to, for this, so this will be 1 and let this be the second. So I'll write 1 plus 2, okay? Is that fine?
Yes.
So that would be, for 1 it would be half of sum of parallel sides. What are parallel sides? One is this 0 to 10 and the other is this 0 to 20. So it is 10 plus 20, isn't it? So it is 10 plus 20 multiplied by the distance between the two parallel sides, and that is what? 2 plus half of sum of parallel sides. Now for this trapezium, the parallel side is this and this, isn't it? This and this, is it? So how much is A to B? 1 plus how much is 2 to 5? 3 multiplied by the perpendicular distance between the parallel sides. So parallel sides are at a distance of 2 to 20. Sorry, 0 to 20. How much is that? Yes? Multiplied by 20. That's it, class. That's the area of this portion. Is that fine? So what is the area? 2 and 2 will go to 1R to 10R. So this is 30 plus 440. So it is 70. Okay? So I can say the area of this portion is 70. Is that clear?
Yes.
Khalas? Now, very important. What should be the area of this portion? Negative 70, isn't it? But you need to understand, he is not stopping at D. The question says, if he for how much time should he continue, so that now this area becomes negative 70. So I don't know, I am saying, let me be at 8, 9, 10, let me be at general time t. So that he should accelerate up to time t, then only the area of this negative portion becomes 70. Is that fine? Now you have to find the area. How do you find the area of this part? Yes? What is this? A triangle. So it is half of base multiplied by height. Do we have the base?
Yes.
What is the base? Half of base is t minus 5, isn't it? But do we have the height? We don't, right? So how will we find the height? You need to understand. We can use the kinematic equations. C. When he is at C, what is the initial velocity? 0? Isn't it?
Yes.
When he is at C, the initial velocity is 0. So we need to know the velocity when he is at time t, isn't it? Because that would be somewhere here. Correct? So that is the final velocity. So we have to find that. Do you know the acceleration? Yes? Do we know the acceleration? No. He started to retard from B. The acceleration is C, it's a straight line. The slope of this line is the acceleration, isn't it? So we know that acceleration. How much is that? Negative 10. So acceleration is known. Do you know the time for which he accelerates? For how much time has he accelerated? Yes? Yeah, we know. It is t minus 5. Isn't it? Because from t is the final time, but his time starts from 5. So the time that he has is t minus 5. Is that okay? So the time that is available is t minus 5. Okay? So we have time, we have acceleration, we have initial velocity. What do you need? Final velocity. Can you do that? Find the final velocity first, and then we will find the area. Yes? Find the... So we know that final velocity is equal to initial plus acceleration into time, isn't it? So we can do that. So we can say the final velocity is equal to initial is 0 plus what is acceleration? Negative 10 multiplied by time. What is the time? Yes? It is t minus 5. Is that clear? So the final velocity would be negative 10 times t plus 50. Is that okay? This is the final velocity. Clear? No problem? It would be negative, isn't it? Why? Because it is going towards the negative direction. Is that fine? Okay. Now, can you find the area of the triangle? What will be the area of this triangle? Yes? Area of this triangle, yes, it will be half of base. Base is how much? T minus 5 multiplied by the height. So we know the final velocity, that is the height. Is that clear? Is that clear? So yes, what we'll do is area of, but the negative portion will be half of base. So base is t minus 5 multiplied it by, yes, the height. And height is how much? See, understand. I'll not write this is negative. I'll not write the negative value. I'll write the positive value because for area is never negative, right? For how will I change it to positive? Yes. Should I write it as 10t minus 50? That will be the positive value of this. Because see, final velocity is negative, isn't it? But when I find the area, it is half of base into height. Height I will not take negative because area is not negative. Area is positive. Then we will convert it into negative because we know below it is negative. But when you find the area, you have to write the height. The value of height cannot be negative. So I will not write this value, I will write the positive value of final velocity, which is this. Is that fine? Is that clear? So try to multiply it and give me the result. Yes, it would be half of. Tell me. First multiply t. How much is this? Is it 10t squared negative 50t? Yes? Yes or no? Yes. You take t, multiply it to 10t, you take t, multiply it to negative 50. Is that fine?
Yes.
Then, negative 5 multiplied by this is negative 50t, isn't it? And then negative 5 into this is plus 250. Is that fine? Is that clear?
Yes.
So, what we are seeing is, we are having a quadratic equation which is 10t square negative 50 times t, 100, isn't it, plus 250. This is what? This is what? Yes? This is the area of the negative side. Clear?
Yes.
Now he is saying that the displacement is 0. If the displacement is 0, then this area should be equal to 70. Isn't it? Because see, the positive area is how much? 70. Negative should also be 70. We found that negative is equal to this. Simply we have to equate it to 70, that's it. So when you equate it to 70, since, I'll write it down, since displacement is 0, so positive area should be equal to negative area. Is that fine? So that means 70 should be equal to this, half of 10t square minus 100 times t plus 250. Is it clear? Can you solve it for me? Find the value of t, use your calculus and get the result. I'll simplify it, then you can put it directly. So it is 140 and that is equal to 10t square negative 100 times t plus 250. Okay, so if you still want to simplify it, you can say your quadratic equation is this: 0 is equal to 10 t square negative 100 times t, and then see, it was 250 minus 140. How much is that? This is a quadratic. Solve it. Get the value of time. Yes? 5 point?
8.7.
5? Is there 5?
No.
Okay.
8.7.
8.7? That's it? 4. Khalas? That's it? So this is your time. But how is it possible that you have only one value? There must be two values.
Yes, 1.2.
Time is equal to what?
1.4.
Both are positive?
Yes.
For this quadratic equation, you got two positive values of time. What is the discriminant? B squared.
Yeah, 2 positive.
So it is a quadratic equation, therefore there has to be this possibility, okay? But you need to understand, we cannot be taking this. Why? Because the time has already passed 6, isn't it? So we have to take bigger time, and that is what? So this is the answer, okay? That's it. Did you understand what I did? We equated the areas, then only the displacement will be 0 and we try to find it. But how do you do that? You need to understand, first we need to find the final velocity, then only we can find the area. So how do you find the final velocity? We use the kinetic equations. Is that clear? So that is it from kinematics. Now I'll give you a sheet, hopefully that will be emailed, okay? You have my email IDs, right? I would like all of you to send me a text or an email so that I can forward the sheet, the quiz sheet rather, so that you can solve that at your places, and tomorrow inshallah we'll be starting with the Newton's laws of motion. Is that fine? If you have any doubt in kinematics, you can ask. Any doubt.
What's your email?
I give you my email ID.
Let me see.
Let's save.
So why don't you make a group so every update you do get
You mean to say this WhatsApp group? Yeah? I'll ask the management. I don't know. This is the same. Munasul Islam, Munasul. Oh no. Is that fine? Any doubt? Anything? You can ask. Okay? Thank you so much.